Hold on guys, you're at the right place. This is our Leetcode video from our 150 series and welcome back. Just imagine you have given with 2, 1 and 4 pounds of weight in a weight rack. But your gym trainer asked you exactly use only 3 pounds of weight. So with the given weights, you can only use 2 plus 1, 3 pounds, but you cannot use 4 pounds, right? This sub-array problem is same kind from the Leetcode. So let's try to resolve it with various approaches. Let's walk through the problem statement given at Leetcode. This is the problem given here with 2 small examples. So the problem statement is given an array of integers nums and an integer k, return the total number of subarrays whose sum equals k. Condition given, a subarray is a contiguous non-empty sequence of elements within an array. Contiguous means nothing but the picked elements should be adjacent to each other. We can also quickly go through the examples given here. In the first example, input array has 3 elements and all are ones, and the given target is 2, so we can form 2 pairs, that is 0th and first indexed values will give us sum 2, and similarly first and second indexed will give us again sum 2, which is pretty straightforward to guess, right? Coming to the second example, input array has 3 elements, that is 1, 2 and 3, and the given target is 3. So here we'll have only one contiguous pair, that is 1 plus 2 will give target sum 3. So now let's start with brute force or naive solution by taking our own input array. Let's say array is having 7 elements as shown here, and suppose the given target is 60. Then in this case there were 3 possible set of subarrays were possible which will give sum as 60. Those are 30, 10, 20, then 20 and 40, and the last element 60 alone, right? So as a brute force approach, we can start with 2 loops. Outer loop is to fix the starting index for the subarray, and then inner loop to iterate from the starting index to the end of the array to calculate the sum. Whenever sum equals k, that is given target, we can increment the counter. So in this way, at the end of the completion of 2 loops, we will have the resultant counter with total number of possible subarrays with given target, right? If you remember, we have followed the same kind of naive approach to solve the 2-sum problem also. Since here we are using 2 nested loops, so obviously the time complexity is big O of n square. The space complexity will be big O of 1 as we only using constant space to store the final resultant counter. Now let's try to write and execute this solution at Leetcode and when in Python. Expecting mostly it will go into time limit problem for larger input arrays. We'll execute and give a try. Declaring initial counter value to 0, then starting the outer loop up to the array size. Inside let's initialize the sum to 0. Then next we'll start the inner loop starting from the first index of outer loop each time. Sum plus equal to current element, that is nums of end. Finally, if sum is equal to k, then increment the counter. On finish of all the iterations, we'll come out and return the counter. That's it, we're done with brute force code. Now let's run it first. So when I click on run, it's executing all the test cases and test cases were passed. Now on submission, there we go. It is taking time, some more time, and finally it's failed. With time limit for a larger input array, this is what mostly expected for brute force or for the nested loops. So I'm just showing up the brute force solution on the screen for your reference here. These are the Python and Java solutions. This code also available at the GitHub links provided in the video description. Now let's move on to optimize our brute force solution. If you are able to recall that in our 2-sum problem, we have used map data structure to find the complements, right? Similarly, here for this case, we can take help of map data structure. So the idea is to first insert the starting value of subarray as key while iterating the array. Then track all prefix sums seen so far and their frequencies in the map. So while tracking, if we see current sum minus k is already encountered, then we'll increment the counter, which means number of times the counter got increments for a particular prefix, we will have that many subarrays. I know you are feeling too much here to understand this logic. Let's take an example with dry run. So this is the dry run table where we will track the start index of a subarray, prefix sum so far, and counter to track the subarrays as mentioned earlier. So let's start from the very first iteration. So at the index 0 we have element 30. A small correction, I forgot to mention our initial sum will assign with 0 before starting the loop. Then current sum minus k is 30 minus 60, which is equal to minus 30. Initially, map will have only one key, that is 0 with value as 1, and it doesn't contain minus 30 so far. So of course, will not increment our counter in first iteration. Next, we will be into the second iteration and previous sum is 30. So current sum will be 30 plus 10, which is equal to 40. So now our sum minus k will be 40 minus 60, which is equal to minus 20, and minus 20 not encountered so far, so there will be no counter increment. And then now we'll update the map with new key, that is 40, and then we'll move to next or third iteration. Observe this iteration carefully now. Current sum will be 40 plus 20, which is equal to 60, right? So current sum minus k will be 0. We know map is already having 0, right? So it's the time to increment the counter now. Also here you can observe so far 30 plus 10 plus 20 will give us target sum 60, right? Which means so far we found one subarray sum which is equal to 60. I hope you are getting the idea now how the counter will be increment when subarray sum matches k. Now the remaining iteration will proceed in the same way, and by the end of all iterations we will have our counter which will have all the possible number of subarrays count. Now we have completed all the iterations, and by the end counter value is 3, which means we have 3 possible subarrays that gives the sum 60, right? For this approach, that is using map data structure, we have iterated through the input array only once, that no nested loops. So the time complexity of this solution is big O of n, and the space complexity is big O n as well, since we are using a map to store the prefix sum in each iteration. Hope you are clear with this optimal approach now, right? Let's quickly write the Python solution for this. Defined a subarray sum method with array and target sum as parameters. Then let's declare and initialize map with first entry 0 and 1 as key values. Then next our initial sum is 0, also the initial counter value as well. Now let's start iterating the input array. For num in the num's input array, sum plus equal to num. Then if sum minus k is in prefix sum map, we will increment the value of the counter. This is the important step in every iteration. Then we'll update the current sum frequency in the map. If sum is already present, then we'll increment the frequency, else we'll put the sum as new entry with frequency 0. And finally, at the end of all iteration, just return the counter as result. That is all about the Python code for our optimal approach. If you have any queries or need clarification with this approach or code, please mention it in the comments. I will definitely reply and will clear your doubts. Okay, now we'll try executing this Python solution on Leetcode. The solution is accepted, of course, and when I submit, there we go. Seems it is absolutely good and no time exceed issues. Now let's quickly write a same logic in Java and we'll execute back here. So now with Java logic also same, and we will use HashMap from Java collections. You can take a note of this, and GitHub links are available in this video description for code reference. So now executing this Java solution at Leetcode, there we go, and absolutely it is fine once again, right? We can also verify the time complexity of this solution here. This is taking O of n, you can see, right? So that is all about this problem and its solutions. Let's summarize it once. As a naive or brute force approach, we worked with 2 loops to find the subarray sum count. This solution is having time complexity as O(n) square and space complexity as O(1). Whereas our second approach using map, time complexity reduced to O of n, but space complexity as O of n due to additional data structure or map, right? Thank you for watching till the end. Please don't forget to like this video and subscribe to BITBEE. Also please share the channel with your friends and see you in the next one. Take care.